Okay. I have a small demo for today. It's an example of pulse width modulation application. Example, step-down controller, step-down converter. It performs conversion from higher DC voltage, in my case 24 volts, to lower, to 12 volts. Schematic shortly is very simple. We have an input DC source, we have a switch which controlled by pulse width modulation controller. Switch activates coil, here is capacitor and load. This diode is needed to discharge coil self-inductance. Yeah, let's now see. Here is my load resistance, this load current, load voltage, source voltage, source current, and I put this analog meter into the source circuit. Also, I have attached a scope at this point where the voltage is shown. Here is what my scope is seeing. It's signal not so easy readable. I will switch to average mode to make it more comfort, let's say. This. Here, it's an average, let's say, to freeze a picture of the coil voltage. Let's take a look what changes if I double the load. I have this resistor. It's going on. Oh yeah, I have disconnected scope. Yeah, I have resistor in series with the load. Take a look what happens when I short circuit it. Can you see it? Come on. Here is the average with resistor and without it. With and without. With and without. You can see change in amount of energy. Coil receives, meaning change of energy. Load receives. You can see with resistor 11.9 volts and without it 11.6. Load change really twice, but voltage remains just the same because of PWM operation, because pulse width controller changes, adapts, let's say, amount of energy to the load for voltage to remain stable. On the primary side, you can see voltage remains stable, but current change near twice to supply necessary energy. Now we can take a look on the other side, another other side. What mean either side? What will be reaction to the change of primary voltage? Take a look. Primary voltage 24 volts, 1.3 amps consumption. 24 volts, 1.3 amps consumption. 1.3 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 volts, 18 volts, 1.7. 16 volts, voltage at load remains stable, but controller now takes nearly 2 ohms. 24, 1.3. 16, it's a stability. 16 volts, 2 ohms. Amount of energy supplied to the load remains the same. We see inversion of ohm law because characteristic of this network is defined not by some its input resistance, but by the control law of the PWM control or control strategy, if you want. Lower voltage, wider pulse, amount of energy load received should remain stable till it's possible. Now it will, you see, operation no longer possible. Here 15 volts, it's on the margin, still operates, still can maintain load voltage stable. Again, change of load. Change of supply voltage.